This video is a video key for the quiz that we had over last weekend. Question 1. A ball is thrown straight downward by a person from a second-story window. The ball leaves the person's hand traveling 8 meters per second. During the trip to the ground, its average velocity is 12 meters per second. What is the ending speed of the ball as it gets to the ground? All right, so we have a person throwing a ball downward. Here's the ball. Have him throwing it downward like this. One way to look at this. All right, so one way to look at this is to make a graph. Make a velocity time graph. And we don't have anything about time, but we really only care about 3 moments of time. When it's first dropped at time 0, when it gets to the ground, and then halfway between there. Why halfway between? Well, because that's when that velocity, the average velocity, occurs. So let's make some little tick marks over here every 4 meters per second. All right, so that's 4, 8, 12, 16, 20, etc. All right, at time 0, the ball had a velocity of 8 meters per second. At time, well, whatever, we don't know what it is, but halfway through the entire trip, its velocity is 12. That's because we know that the average velocity occurs at exactly halfway through the time interval. If you don't remember that or understand why, I suggest you go back and watch the video related to that. All right, from there then, we can just draw a nice straight line and out to our graph here and see that that reads over to be 16 meters per second. And so the ending velocity must be 16 meters per second. Now here's another way to look at it. Imagine that you had 2 test scores. You got an 8 on one test, and you got something on the other test you don't know. But you know the average of both of your tests was 12. What number would you have to get an average of 12? All right, well, what would 8 add to such that when you added them up and divide by 2, you got 12? And the answer is that would have to be 16. So the same thing works as long as there's constant acceleration, which we are assuming there is. The same thing works for velocities. Started at 8, average of 12 meters per second, have to end at 16. All right, this is question 2, and it's the same kind of question. It's a little bit more challenging because, in fact, we're not given the average velocity, but we have enough information here to determine it. And so we can again say, hey, we have at the end, our car is, at the end of its motion, the car has a speed of 70 meters per second. And on average, it has a speed of, well, let's figure it out. 100 meters per second is the displacement. 2 seconds is the time for it to make that trip. That's 50 meters per second. So on average, 50 meters per second. All right, if you end at 70 and you start at 50, what number, when put together with 70, will give an average of 50? Well, let's see. 70 plus something over 2, adding them up, divide by how many you got. 2 needs to be 50. All right, well, what would go in there to make that 50? And the answer is 30 meters per second. Here's a question where we're supposed to interpret this graph. Here is a velocity time graph for an object in motion. Which of the possible scenarios could this be a graph of? Well, we don't have to guess. What we should first do is figure out how can we describe the motion of this object. It's a velocity graph, so we start with a large velocity and go to a smaller velocity. Therefore, this thing is slowing down. Now, we might need to know more than that, but let's just check our choices. A person on a Ferris wheel. Well, they're always changing the direction that they're going, and this guy has always got a positive velocity. Plus, a Ferris wheel travels at a pretty steady speed around, not slowing down, so that's up. A car traveling a steady speed back to where it started. Who cares about that part? It says it's traveling a steady speed. This thing is slowing down. Off. So a soccer player sliding across a field. If a soccer player slides, they are going to slow down. That is a distinct possibility. A ball rolling down a hill. All right, I agree this is sloped down, but this isn't a picture of the hill. This is a velocity time graph, and this has the velocity from going from 12 to 4. This is like the speedometer reading on the object. So this object's slowing down. A ball rolling down a hill is going to speed up. So that's right up. So the proper answer is D. All right, given the velocity time graph below, determine the displacement of the object during the first 4 seconds of its motion. That's right up to there. All right, velocity time graph. How do I get the displacement? Well, it's either the slope or it's the area. All right, let's see. The area would be the two axes multiplied together, meters per second times seconds. That would give us meters. Yep, that's the units of displacement. Let's double check. The slope is meters per second divided by seconds. That's meters per second per second. That is not displacement. So yes, the area is what we want to look at. And we might notice that we've got a triangle and we've also got a rectangle. The triangle then will be, so let's come down over here. Triangle area will be 1/2 base times height equals 1/2. The base is 4 seconds long. The height is 8 meters per second high, and that's going to be 16 meters. But there's also this rectangle in here, and so the rectangle area, that's going to be base times height, or 4 times 4, 4 seconds, 4 meters per second is 16 meters. Total that up, 32 meters. Next question, the object moves as shown on the graph. Determine the acceleration. Well, as we saw before, the acceleration is related to the slope. All right, so let's find the slope of that thing. Rise over run. Well, let's see, the rise, it goes from 12 to 4. That's a rise of -8. And the run is from 0 to 4 is 4 seconds. So -2 meters per second per second. All right, an object's motion is represented by the motion diagram below. It moves to the right. At the first black dot there, the object is not at rest. So determine the acceleration. All right, so what we're going to do is, to find acceleration, we need two velocities. We need a final velocity, we need an initial velocity. One earlier, one later. And then we need to divide that by the time when that velocity happened and the time when that velocity happened. So let's go get ourselves some velocities. Now, we only have the ability to find the average velocity. Let's say this is for interval 1 and that's for interval 2. That's going to be the displacement during interval 1 divided by the time interval for interval 1. The displacement is, from here to here, is 1.5 meters. And the time interval, see, that's 0, 1, 2, 3 seconds. All right, so that is 0.33 meters per second. Now let's get the average velocity for the second interval. And the reason is because we need two velocities. There's one of them. Now we're going to go get the other one. Okay, that's 2.5 meters. And let's see, that's time 1, 2, 3, 4 seconds. But it started at 1, so the delta t is actually 3 seconds. 0.83 meters per second. Now, I also need the time when those velocities occurred. That velocity occurred exactly halfway. It's the average velocity occurred halfway through that 3 seconds. So that happened at 1.5 seconds. This one also occurs halfway through that. That is 3 seconds long. So it occurs halfway through there, or 1.5 seconds. But it's one. All right, picking up Again, this velocity occurs halfway through that time interval. That's 1, 2, 3 seconds worth of time. Halfway through there's 1.5 seconds. But that time interval started at 1 second. So that's 1 second plus the 1.5 seconds through the interval, or this occurred at 2.5 seconds of time elapsed on the clock, if we had a clock running. All right, well now we can find our acceleration. The final velocity, 2.5, that is the second velocity here. The initial, 1.5, divided by, whoops, that's not right. The ending velocity, or the second velocity, is 0.83 meters per second, and the beginning is 0.33 meters per second. That's our two velocities. And then time interval from 2.5 started at 1.5, or in other words, this velocity occurred at that, this velocity occurred at that time, this velocity occurred at that time. Okay, so then this will be 0.5 over 1, or 0.5 meters per second. And the last question we're going to deal with in this video, which of the following is not a vector quantity? Acceleration has direction, not a vector quantity. Time is not a vector quantity. Speed is just how fast, not what direction. That is not a vector quantity. Mass, not a vector quantity, but velocity is. That's the answers right there.